Question number 4. This question is about zinc and compounds of zinc. A student produces pure crystals of zinc chloride by reacting zinc oxide with hydrochloric acid. The equation is given to us here. Zinc oxide, which is solid, it is reacting with hydrochloric acid, and as a result of this, it produces ZnCl2 and water. So this is basically metal oxide reacting with acid, producing salt and water. Says the student adds zinc oxide to hydrochloric acid until the zinc oxide is in excess. If I look at this equation, I can see that zinc oxide is solid. So if you put it in excess, then the solid will stop disappearing. And that's how you will know that the zinc oxide is now in excess. It says, give one observation that the student could make to show that zinc oxide is in excess. So you'll say, no more solid will disappear. Next part says, why is excess zinc oxide used rather than excess hydrochloric acid? Going back to the equation, I can see acid is in liquid state. Now removing liquid from liquid products is very difficult, but solid from liquid can be easily removed. So we can say ZNO can be removed easily. And what process will you follow for this? Process will be filtration. Next part says, name one other compound that the student could add to hydrochloric acid to produce zinc chloride. Now, zinc chloride is my salt. It can be produced instead of using zinc oxide here. I can also use zinc hydroxide. I can also use zinc carbonate. So I can say could be zinc hydroxide, or I can say zinc carbonate. Next part says, describe how the student could obtain crystals of zinc chloride from a solution of zinc chloride. So you've been given a solution of zinc chloride and you have to extract zinc crystals from it. The first thing that you will need to do in this case is you'll have to remove the water from this solution. So you'll say heat solution until saturation point. For heating purpose, you will use Bunsen burner. Next part, you will let it dry naturally. Once it dries naturally, you will get the crystals. It then says zinc chloride is also produced in a displacement reaction between zinc and copper chloride solution. The equation for the reaction is given. So this is a displacement reaction taking place. You add zinc to a solution of copper chloride, and as a result of this, copper comes out as solid. Zinc chloride will become a solution. Now this reaction will take place because zinc is more reactive than copper. It asks you to write down the ionic equation for this reaction. Before I write the ionic equation, I will write down the charges of all of these elements involved in this equation. So I can say zinc has a charge of 0 because it is in the unreactive state. Copper chloride is in the form of compound. Copper will have a charge of 2 plus and chlorine has a charge of 1 minus. Now on this side, zinc has a charge of 2 plus, chlorine has a charge of 1 minus, and this copper has a charge of 0. Now if I compare the two sides, there is something that has not been changed. For example, chlorine was 1 minus on the left side, and chlorine is 1 minus on the right side as well. So I can say this and this will cancel out, and these are called spectator ions. These are called spectator ions. Whatever is left, you just write it down in the form of equation. Zn has a charge of 0. Copper will be Cu2 plus. Zinc is now 2 plus on the right side, and copper will be just solid with 0. It then says, why is zinc described as being oxidized in this reaction? So if you recall, Weolric oxidation is the loss, reduction is gain of electron. In this case, I can see zinc was 0, it has now become 2 plus, so it means it has lost 2 electrons. You can say zinc lost 2 electrons. Next part says zinc and copper can be used with another substance to produce electricity. Complete figure 7 to show how zinc, copper, and another substance can be used to light a lamp. Label 3 things: zinc, copper, and the other substance used. So this is our electrochemical cell. I'll need a beaker here. In this beaker, I'll have 2 electrodes. Let's say this one is zinc, this one is copper, because they both have different reactivities. That's why the movement of electrons will take place. But we will need something for the movement of ions to take place, and that will be our electrolyte solution. So this is our electro. It's a chemical cell. Remember, in chemical cell, our output is potential difference, and that's why the lamp will light up. If it was the electrolysis process, then instead of lamp here, you will have to supply energy in the form of cell. So that's the biggest difference between a chemical cell and the electrolysis process.